f double prime, that's the second derivative of f, is given sin x plus cosine x, and the function value at 0, that's the x value. When x equals 0, the function takes 3. That's an initial condition. And f prime at 0 equals 4, initial condition, just to determine the unknown arbitrary constant. We need to find the function f. Okay, so second derivative, so we find an antiderivative, we get first derivative, and do one more time, we get function. So it's a two-step problem. Then the function first derivative, the antiderivative of second derivative is first derivative, which is the derivative of f prime is second derivative. Okay, give me a function whose derivative is sin x. We know cosine x, derivative of cosine x is negative sin x, but there is no negative, so we put negative here, plus give me a function whose derivative is cosine x, that's sin x, because the derivative of sin x is cosine x, and plus 0 is always there, and we can always write c, a constant, arbitrary constant c. So f prime x equals negative cosine x plus sin x plus c, f prime, and we have an initial condition in terms of f prime. Okay, when x equals 0, f prime is 4. So using this initial condition, we can find the value of c. Okay, so using f prime at 0 equals 4, we get, so f prime is 4 equals negative cosine x is 0 0, cosine 0, just cosine 0, what is the value of cosine 0? That's 1, plus sine 0, sine 0 is 0, plus c, so that gives us c. C is negative 1 plus 0, negative 1, move this over, that means add 1 both sides, so 4 plus 1 5. Then we can rewrite the f prime of x is negative cosine x plus sin x plus c, c is found to be 5 plus 5. Okay, that's the f prime, first derivative. But question is to find the function, so we need to repeat the procedure. We need to find antiderivative, then we get fx, we'll have an arbitrary constant, use the other initial condition to determine that constant. Okay, so this is f prime, then the function is negative is there, give me a function whose derivative is cosine x, that's sin x, plus give me a function whose derivative is sin x. We know derivative of cosine x is negative sin x, but there is no negative, so we need to put negative here, plus give me a function whose derivative is 5, that's 5x, derivative of 5x is 5, plus arbitrary constant, because plus 0 we can always write, so let's write down c is already used, let's say d. Okay, now we need to determine the value of d. For that we use this initial condition, f at 0 equals 3. When x equals 0, the function value is 3. So using f at 0, f0 equals 3, we get f is 3, so this f value is 3, equals, we need to plug in x equals 0, so minus sine 0, sine 0 is 0, so minus 0, 0 doesn't matter, just 0, plus minus minus cosine 0, which is 1, plus 5 times 0, just 0, plus d. Okay, 0 minus 1 plus 0, negative 1, add 1 both sides, 3 plus 1 4, so d equals 4. Now substitute this into here and we have the function. Thus the function is negative sin x plus minus minus cosine x plus 5x plus d equals 4, so plus 4.